What coordinate on the graph of that function is closest to the point 10, 0? Probably should have included a graph of this one, but I didn't. Sorry. Let's go all the way to 10. 2, 3, 4, 5, 6, 7, 8, 9, 10. And let's graph that function by hand in our heads. We got this. This is a square root curve. Square root curves go, it's like a inverted parabola, but only one leg of it. And it's not like it, that's what it is. And this one is shifted 4 to the right. There we go. And it goes like that. Maybe not quite that steepness, but it goes like that. So here's the deal. I want to know what point is closest to that point right there. And I don't know, is it this one? Is that one closer? Or is that one closer? Or is that one? Or is that one? Well, let's be honest, it's not this guy. And it's probably not that one. It's probably here-ish, something around here, maybe. I just don't know where there is. So that's the question. Final answer will be, what is that coordinate? That's what we're dealing with. So how are we going to do this? Closest. That sounds like distance to me. And back in the day, there was a distance formula, which I will write in red. And the distance formula is very difficult to memorize for a lot of individuals. But in a minute, I'm going to go off script. Not that I have a script, but I'm going to go off script and tell you where it comes from, just so you know. And it's actually really easy once you realize that. So x2 minus x1 squared plus y2, not y squared, sorry about that, second y minus my first y, and that is also squared. And real quickly, let me tell you where that comes from by grabbing a scrap piece of paper and drawing a right triangle. There we go. A, B, C, look familiar? A squared plus B squared equals C squared. If I wanted to know the distance, let's start this here. If I wanted to know the distance from here to here, I could do A squared plus B squared. Well, now that we're in a coordinate plane, if I want to know the distance from here to here, we'll turn this around. I can find that distance, and this distance is the distance I get by subtracting a couple of x's. And this distance is the distance by subtracting a couple of y's. And that is the distance I'm looking for. So this distance is x2 minus x1 in no particular order. And then squared plus y2 minus y1 squared. Whoops, let's get on camera, that'd be nice. Equals the distance that I'm looking for. And it is squared. Well, if I wanted to solve for distance, I'd square root the whole thing, and there's your distance formula. Yay! All right, now you know. All right, back to the problem at hand. We are going to find the closest point. Closest point means minimize distance. Minimize distance. I'm going to write that down just so we are not reading that problem later saying, what was it asking? So minimize distance. We're going to have to take the derivative of this in a minute. It sounds disgusting. Actually, we're not going to take the derivative of it. Trust me, much easier than you think. All right, here goes. Let's jump in. What color do you want me to use? Purple? Sounds good. We're going to use this point and this point. And I don't know what that point is, but we'll just deal with it. So the distance equal to let's stick with red. Nah, let's go purple. And I spend the next 5 minutes wasting your time going back and forth. Distance equals square root. That's 10, 0. So that will be 10 minus, what's that point? I don't know. Who knows? Just leave it blank. And then y2, which is 0. And what's that point? I don't know. Let's leave it blank. Okay, I don't know what it is. And that's the question. But here's what I do know. I know that this point is on that function. So this point satisfies this coordinate. That's it right there, okay? I just lied to you by accident. That is not the coordinate. That's way wrong. Okay, full disclosure, I'm really hungry actually. And when I'm hungry, I don't do optimization problems well. The coordinate here is x, then y, and y is defined as the square root of x minus 4. Whew, that was tragic. Man, glad I caught that mistake. We'd be here all night. I wouldn't get any supper. 10 minus x, and then this is the square root of x minus 4. Okay? So your x. I don't know what the x is, but the y that corresponds to it comes from that. All right, let's find the derivative of that. Do you want to find the derivative of that? Me neither. Let's not. Well, let's simplify first, whether we find the derivative or not, but we're not. All right, let's go ahead and square that guy. That gives us 100 minus 20x plus x squared. That's what we get when we multiply that. And when we square this one, there is no foiling to do. That 0 just goes away. We square a negative, becomes positive, and we square the square root, and we have x minus 4. So what we're really going to have is the square root of 100 minus 19x plus x squared. Oops, not 100. It's actually 96. I apologize, 96. I better just turn the video off now and get some supper. Hungry. All right. Another bit of full disclosure. When I first worked this problem out, I found the derivative of that and used the chain rule, and it was gross and disgusting, and I'd love to show you my work, but it ended up in the trash. And it was nasty. Nasty, okay? In order, though, here's what we're aiming for. We're wanting to minimize distance. In order for this to be a minimum, then the innards, that's not a mathematical word. That's what I say when I'm hungry. But the inside of the square root needs to be a minimum. So I'm going to write down my thoughts here. Let's minimize this. That's what I'm really doing, okay? In order to minimize this entire thing in its square rootedness, then we just need to minimize that. That's it, okay? So take the derivative of the whole thing if you want to. I'm not. I'm going to take the derivative of that, which is negative 19 plus 2x, and we'll set that equal to 0, and x is 9.5. Okay, that's not a coordinate, but we're getting there. So what coordinate on the graph? Final answer is 9.5 comma, I don't know, but it's about to come out into the open, about to become very clear. I don't know what I was trying to say. I'm gonna run to the microwave as soon as I stop this thing. Video's over, time to eat. The square root of 9.5 minus 4 is the square root of 5.5. Let's just stop there because it's supper time. No, let's stop there because that is sufficient and because it's time to eat. So 9.5, which is somewhat accurate with what I had, looked like it was about 9, and then the square root of 5.5 would be the coordinate. Supper time. Enjoy.